All right, Algebra 2, working on the study guide for the Unit 9 test, and this is starting with question number 10. This is the third video. All right, number 10, it's just to simplify log base 5 of x cubed plus log base 5 of x cubed. So I have two logs with the same base, and I am adding them, which means I would multiply the argument of each log. So it's going to be log base 5 of x cubed times x cubed. And remember, with our properties of exponents, we are multiplying the terms, 1x cubed times 1x cubed, but the rule for these exponents is that they add. So this would be log base 5 of x to the 6th. So we did multiply, but the exponents themselves end up adding. And here's the thing, guys. Remember that a log is an exponent. So if you're wondering, well, how couldn't I have just added? Well, each log is an exponent, so technically that's what we did. So for B, you would be dividing, right, log base 4 of x cubed divided by x, right? And then remember, the rule for those exponents is they subtract, which is why the problem is subtracting. It's why these properties work the way they do, because a log is an exponent. So this is just log base 4 of x squared. All right, and that first one was log base 5 of x to the 6th. Okay, 11, I'm just rewriting from log form to exponent form. So we've looked at a problem like that, so I'm going to keep going. Number 12 says to evaluate. All right, so I have the log base 3 of 54 minus the log base 3 of 6. So I could evaluate each one and then subtract my answers. I could also use the property of logs that allows me to combine them. So I'm actually going to do both. So if I did log base 3 of 54, right, I could do that. Log base 3. Let me actually use change of base on this one. So if you're doing change of base, you do the log of the result divided by the log of the base. So it'd be log, okay, now we get a decimal, and then log base 3 of 6. So log of 6 divided by log of 3 is 1.6309. Notice those decimal endings are like almost the same. So then I'm going to take this answer minus my most recent answer. That's a trick too. If you do second and then your negative button where it says ANS, it brings up your last answer. You don't have to retype all those decimals. And I just get 2. And here's the thing. If you rounded those off, it should probably work. So again, that's one way to do it. Evaluate each one. And we got 2 when we did that. Sorry. Let me get focused here, my bad. So then, but an easier thing, or another way to do it, would be to just combine these into one log. And because they're subtracted, I would do that by dividing the two results. So it would be log base 3 of 9, which, again, remember, a log is an exponent. What exponent do I raise 3 to get 9? Well, 3 squared is 9, which, as we just found a minute ago, would be 2. So you're going to, if you combine the logs, you're probably going to be able to evaluate with mental math and not need the calculator. All right, we're expanding in number 13. So remember, this is where we have multiple things crammed into one log, and we want to write them out separately. So if we look at, let's actually do B here. All right, so I have log base 4 of 5x cubed divided by y to the 5th. All right, so all of this is in one log. I want to write it as separate logs. So again, using our same properties that we've been talking about, when two logs are subtracted, we combine them by division. When two logs are added, we combine them with multiplication. We can go the other way. So where log base 4 of 5x cubed is divided by y to the 5th, I can write those separately by using subtraction. So it'd be log base 4 of 5x cubed minus log base 4 of y to the 5th. Okay, undoing that property of division. So then now the first log I have is 5 times x cubed. That's multiplication. I can split two logs being multiplied with addition. So it would be log base 4 of 5 plus log base 4 of x cubed minus log base 4 of y to the 5th. The last thing we want to check, and you may have already gone ahead and done this step as you were getting here, is we don't want to leave any exponents on the end. We're expanding this back out, so we don't want things put back together. It's like taking apart a Lego tower. We're taking all the pieces off. So I'm going to move both of these exponents on these logs back to the front. So I would write it as log base 4 of 5 plus 3 log base 4 of x minus 5 log base 4 of y. And that would be my expanded answer. Okay, moving on to number 14. It says to evaluate. So again, evaluate means find a numerical value. What value does this have? And again, we could use the calculator, but this is kind of like some of the problems we did on the front. If we move this exponent, we'll probably find it easier to do this with mental math. So if I make this 9 times the result of log base 3 of 81, so I moved my 9. So 3 to what exponent equals 81? That's 3 to the 4th. All right, so then I just have to do 9 times 4, which would give me 36. All right, so the properties just allow us easier ways to do these with mental math. And before people could work logs out with calculators, this was the best option they had. All right, I'll go ahead and look at 15. So it says to solve for x. So I've got 2 logs here. All right, log of 30x minus log of 3 equals 2. So when I'm solving the logs, I just want a single log on one side. So I need to combine these two by dividing. So I'm going to divide. So it's going to be log of 30x divided by 3 equals 2. So 30x divided by 3 is 10x. So that's log of 10x equals 2. And then to get rid of the log, I need to rewrite it in exponential form. So this is log base 10. We know that when the base is not written, it's 10. So if I wrote this in exponent form, it would be 10 squared, the base to this exponent, 10 squared is 100, equals this result, 10x. So if 100 equals 10x, I divide by 10, and x equals 10. All right, b is pretty similar, but you would actually multiply on b because it's log of 50 plus log of 5x. All right, so you'll find the next few problems in the next video.